So we are going to start with this symbol right here in our first row, less than. I do not like that they say less than because less than means subtraction. We're going to include the word is. So would you insert the word is in there? When we read that symbol, we're not going to say less than. We're going to say is less than. And notice on the graph, when we graph that symbol, we are including all the numbers going to the left. Those are the numbers that get smaller and smaller. And notice that they have a circle there, but they did not shade it in. And the reason they did not shade it in because it is not included. The only ones that are in there are the ones that, remember, that are equal to. So in this next one now it's the same symbol, but it has that little bar underneath it. So this one is less than or equal to. So insert that word is there, please. Is less than. So we're on the second row. Is less than or equal to. You also might see words used like no more than. So if they say 6 is no more than 8, they're saying 6 is less than 8, okay? Or at most. Okay, and notice what's different this time. It is still shaded to the left where the numbers get smaller, but the circle is shaded in because the equal to part is there. That number isn't also included, okay? And then we talked about when it's pointing to the right, that means is greater than. We're going to insert the word is again. Is greater than. And notice on the graph, when we're graphing those, we are shading to the right. And this one does an open circle because the equal to part is not there. But in the next one, the equal to part is there, that little bar. You can't see it very well. The little bar is there saying equal to. And so then we shade to the right. And the point is also included by being shaded in. So those are all things that we want to make sure that we watch out for when we're looking to see what an inequality is, or we have to write the inequality. So let's look at that first set here. Match each inequality with its graph by using the letter on the line. Okay, so we have to match this one right here with either A, B, C, or D. So what do we need to look for? Well, it has the is greater than or equal to bar. And then it has that -4 there, which means the endpoint should be -4. So which of these should it be?
D.
B?
D.
D. Okay, why is it D, Adam?
Because it shows -4 and then the X on the line. The dots on the -4 and plus it's.
Why is it shaded in?
Wait.
Why should it be shaded in? Do we want the shaded in one? Because of the equal to bar, so we want a shaded circle, so it has to be shaded in. So that part's correct. How about the direction it is shaded? Is that correct?
Yeah.
Because what does this read? Tell me what this reads. X
is greater than or equal to 1-4.
Yeah, X is greater than or equal to -4. So basically it's saying any number you put in there for X from your graph better make that true. So let's pick a number that's in that, going that direction. Let's pick 0. That's kind of a nice number. Is 0 greater than -4? Yeah, so it's shaded the correct direction. Okay, how about the next one? What does that one read?
B.
What does it read, first of all? X is what?
X is less than or equal to.
X is less than or equal to -4. So do you agree with Preston, you guys, that it's B? Because it's shaded in at -4, that's the equal to part. It's shaded to the left, that's the is less than part. So it looks like it should match up with B. Okay, what does the next one read? Maisie, what's that next one read?
X is greater than -4.
Okay, X is greater than -4. Is -4 included? Should it be shaded in other words? Is -4 included? X is greater than -4. Can X be -4? No, so that means you've got to have an open circle. X, though, has to be greater than -4, so which ones of those would be -4, not shaded in, and it should be shaded which direction? To the right. So which one is it? A, looks like it matches up with A. Now, not by just process of elimination in case they're trying to trick us. Should we just put, if the last one's gonna be C, we need to make sure. Okay, so X is what? What does this say? X is
Listen.
less than -4. So -4 can't be included. So does C pass the test there? Yeah. And is less than means it better shade to the left, so it looks like it passes the test, so it can be answer C. Okay, now that we know how to do this, we're going to write the inequality shown by the graph, okay? So, first one. First of all, there's always an endpoint. You gotta decide if the endpoint is part of the solution or not. And then you gotta decide what other numbers are also part of the solution. So anybody think they know which inequality statement we could write to represent that number line graph for the first one, Blake?
6 is greater than
6 is not greater than 9 though, so that's, first of all, and we want an X in there. Okay, let me clarify something for you. The shaded region is our variable because we cannot, we can't begin to name all of the possible relationships. So X is our shaded region, and then we're describing that shaded region. So it's always going to start with like X or another variable. So X what? Is greater than 6. Do we need the equal to bar? It's not shaded in, is it? It's not shaded in. So here's what you do. You kind of test it now. Now, Blake, we would say, how about we pick 9 because 9 is from the shaded region. And we say, is 9 greater than 6? Yeah. So what they really don't show is it really keeps going on and on and on. You might have been deceived thinking it stopped at 9. It doesn't stop. It keeps going forever in that direction. Okay, you guys go ahead and try and write the inequality statements that you think those other 3 are representing. What you're really doing is writing the algebraic solution given the graph solution. And remember, the shaded region is your variable, whether it's A or B or X or Y or whatever you use. Okay, Seth, bring your paper up. Will you put your 3 answers up there for us, please? Thank you. Thanks, Seth. Okay, do we all agree with Seth? So how do we decide when the equal to bar is part of it? Yeah, when the endpoint, the circle is shaded in. How do we decide when it should point, when our inequality symbol should point to the left? When our inequality symbol is, when should it point to the left? When what? When the graph is shaded which direction?
Right.
To the left. Actually, when the variable is on the left side like this, you can read it just like this. The shaded region should be less than, it should be going to the left of your endpoint. When it is pointing to the right, we're saying our shaded region, X is the shaded region, X should be going to the right greater than, so we want to make sure that we always understand how to write that correctly. Now, some of us tend to like to do this. Does this mean the same thing? For this one right here, this is the one I'm talking about. Would that be right? Could I count that right? What do you think? -2 is greater than or equal to X. Remember what words can we replace X with? The shaded region, the shaded part. Anything that is shaded. So, do you think we could write it this way? Okay, here's how we could check it out. Remember, this one says the shaded region, this one right here says the shaded region has to be less than, is it less than? Or equal to, is it equal to? -2, right? This one says, this one right here says -2, here it is right here, can be equal to the shaded region, so, or it has to be greater than the shaded region. Is -2 greater than all of these numbers? Is -2 greater than -5?
Yeah.
Yeah. It's better for it to be 2 below outside than 5 below, right? So this is another way we can write it. And there are students that actually prefer the second way here. They will write it that way because that makes more sense to them. Do the one that makes sense to you. I can't count that wrong. I can count this wrong, though. That would be wrong. -2 is less than or equal to x, also known as the shaded region. -2 is not less than these numbers. Any number to the right of another number is always greater, always. Okay, let's go to the back side, and let's do some graphing. Here's how I'm going to have you graph. I'm going to have you do this a tiny bit different than the book does, because they can get kind of monotonous and tedious to have to do if you have to make really detailed number lines. So here's what I have you do. I have you put the endpoint that's given kind of like somewhere in the middle of the number line. So we're going to use that tick mark right there. Okay? And then I want you to identify the integer neighbors, one on each side. Integer, remember, integers are the whole numbers and their opposites. So -7 is an integer. What is the integer neighbor that we could call this mark they have right there? What integer neighbor lives right to the left of -7? -8. What integer neighbor lives to the right of -7? -6. So what we're really going to do is we're going to just make a number line like this, okay? We're going to put a -7 kind of in the middle. We're going to say -6 lives over here to the right. But however far away we make -6 to the right, that's how far away -8 has to be to the left. We have to use good number line sense. They have to be, so this is 1 unit of distance, so we have to have about the same for the -8 over here. Okay? So that's what I want from you. I want you to have 3 numbers labeled on them, and I want the integer neighbors, even when they're fractions or decimals, and we'll do that in a little bit.
What
So-
happens if we put 1?
It won't hurt.
Okay.
Okay, let's put our circle at -7. That's our endpoint. And then we make this decision. Should we shade that circle in or not?
No.
No, why not?
Because it's not equal to.
Because there's no equal to bar there. It is not equal to -7. It is greater than -7. So which direction should we go? To the, what numbers are greater than -7? These guys, yeah. Shaded dark, thick, so we can tell which numbers you're including. And then you pick a number from there and make sure it makes it true. So let's pick like -6. Is -6 greater than -7?
Yes.
Okay. Okay, let's go make a number line for this one. Or make our own new one.
Are we just gonna put our own for everyone?
Yeah, we're gonna put our own. Okay, so we're gonna put 8 there. And then we're gonna say, okay, yeah, 8 has an integer neighbor this way, and same distance away over here, it has another integer neighbor. So what's the integer neighbor to the left of 8? To the left?
Or
6.
And to the right, 9. Okay. We have to have good number line sense. We put a circle at our 8, because that's our starting point. It's our end
We
point.
shaded it.
Do we shade it in?
Yes.
Okay, because
Because it's equal.
the equal to bar is there. And what other numbers are also part of this solution inequality? P can be also greater than 8. What numbers are greater than 8? This way, to the left, or to the right? To the right. Is 9 greater than 8? Okay. so this next one, I'm just gonna kind of make my own here. This is one of those that was like that one I said, some students like it this way. This one doesn't have the variable on the left, it has it on the right. So when it's on the left, 2.5 is greater than or equal to R. Anybody know how I could also write that so that it's on the left? R is what?
Less than.
Less than or equal to 2.5, yeah. So if turning it around helps you out, so notice what happened. The R and the 2.5 traded places and the symbol reversed, didn't it? So the R and the 2.5 traded places and the symbol reversed. Okay, so now we will put a 2.5, that's our endpoint. Equal distance away, we will put integer neighbors. Integer neighbors. So what's the integer neighbor to the left of 2.5?
2.
2. What's the integer neighbor of 2.5 to the right?
3.
3. We'll put our circle at 2.5. Shaded in or not?
Yes.
Yes. Okay. And which direction should we shade this one? Okay. So if we shade it to the right, let's see if it makes it true. I'm going to pick 3 then, because 3 is to the right. Okay. 3. Is 2.5 greater than 3?
No.
Is 3 less than 2.5?
Yeah.
No, it doesn't work. So we need to shade to the left. So we have to make sure that any numbers we choose from our shaded region make it true. So now let's pick 2 because it's in the shaded region. Does 2 put in either of them make it true? Should in both of them. Okay, so let's check it out. Is 2.5 greater than 2? Yes. Is 2 less than 2.5? Yes. Okay, this is the direction it should be shaded. Okay, you go ahead and graph the last one on your own. And then you can look up and see if you agree with mine. Try and do it on your own first, though. When you're done, then you can look up and see if you and I agree. Or if you need to challenge me. Y is less than -1, it says. So all the shaded numbers should be less than -1. So we have to have good number line sense in this chapter when we're working with inequalities because we will always graph them. Okay? Any questions?
No.
Okay, we only have about 5 minutes left here, so we gotta move on to this last section here. For each situation, it says define a variable. In other words, pick your variable and tell what it represents. Then write an inequality, and then it says graph it. Okay, so they kind of have the graph set up for us. It looks like. To enter the play area, children must be more than 4 feet tall. To enter the play area, children must be more than 4 feet tall. So what do you think our X could represent in this problem? What's the thing that can vary? Their height. So X is child's height. You know, there are places like, Valley Fair, when you go there, you have to be a certain height to ride on a ride. So X is child's height. What inequality statement could we represent to show which children's heights are allowed in this play area?
4.
Well, I think it's always best to start with the variable if you can. The child's height must be what? 4. Okay, well then what symbol is going to go between there then?
Must be greater, so should be this.
The child's height must be greater than 4. How about equal? Can the child be 4 feet tall?
Yes.
No, it doesn't say that. It says must be more than 4. Can they be 4? No, so we can't include the equal to bar. So we're gonna put our open circle at 4. And we're not gonna shade it in because a 4-foot tall kid can't go in here, sorry. But all the people that are more than 4 feet tall can. All the kiddos that are more than 4 feet tall can. Okay, the next one. As of July 1988, the speed limit on the rural interstates in Virginia is 65 miles per hour. So what can vary in this problem? Do you have to drive the speed limit first of all?
Yep.
No.
You can't go over the
Yeah, yeah. So can the speed limit, can the speed you're driving vary? Can the speed you're driving vary? Yeah, so X is the speed. Let's say driving speed. X is the driving speed. X, speed limit is 65 miles per hour. Speed limit means you can't do what? Go over that. Can you go that?
Yes.
Okay, so what would our inequality symbol be? 65 is going to be over here, right?
Less than or equal to.
So the speed you're driving has to be less than or equal to 65. So we come over here and we put a closed circle at 65 because we can drive 65. But can we drive this way, going this way, 70, 75, without the chance of getting a ticket? Probably not. So we're going to have to go this way, aren't we? Okay. And there's actually a restriction there, but we'll worry about restrictions maybe a little bit later, not right now, today. Okay, now we got Josephine, who's sleeping less than 8 hours each night, which probably is most of you, right? Yeah. Okay, so what is the variable in this? What can vary?
Sleep.
The amount of sleep is hours of sleep, right? So the first and most important thing is we know what our inequality is representing. We describe that, and then we say X, and then we see that there's an 8 there, so we know 8's going to be over here. It says less than 8. That's pretty cut and dried, isn't it? Is less than. Can it be 8? No, does it say?
No, it's less than.
No. Is less than 8. So 8. Do we shade in our circle then? No. And what direction do we shade? To the left. Okay, they did not put any extra numbers on here, so we have to. So we're going to make this one what? 9. We're just kind of skipping over those. And we're going to make this one 7. Okay. And we shade to the left in this one. And again, there's actually some restrictions here, but we'll worry about that. Hey, you need to quickly get the assignments going down. You have due for Monday. These are the things you should be practicing in your homework.